what technique can you do to solve without having to get a common denominator? Yeah. Cross multiply. If it's a single fraction equaling a single fraction, I can cross multiply. So this is just Algebra 1 review all over again. 20x plus 25 equals 2x minus 2. And then we just solve. Subtract your 2x's over to the left. Subtract your 25 over to the right. We have 18x equals negative 27. Divide by 18. Negative 27 18ths, those are both divisible by 9, so negative 3/2. So cross multiply, and now fraction's gone. It's just a linear equation to solve. In B, when we cross multiply, it's going to turn into a quadratic. So when you FOIL this, you're going to get x squared minus 6x plus 1x minus 6 equals, cross multiply, 2 times 2 minus x is 4 minus 2x. And with a quadratic, you just have to immediately know get it equal to 0. So add your 2x over, subtract your 4 over. So I will have x squared. How many x's do I have? Negative 3. And then minus 10. And then factor to solve. So x minus 5 and x plus 2. We'll do the trick. So x equals 5 or negative 2. If you go back and look at your original equation on this one, this is something that you're going to have to be more mindful of that linears and quadratics don't have, but rational functions sometimes do. What x values in the original would make things undefined? Two and 6. So if we were to have gotten an answer of 2 or 6, we would have to reject that. Okay? Because it would be extraneous, and that will happen. So you might want to look at that right from the beginning and say, okay, what x value will I have to reject if I get it? 0. 0 would make these denominators 0. Think about that. You can write that over on the side if you want to keep track of it. X definitely can't equal 0. Now, this is something on which we cannot cross multiply. So, the steps for solving rational equations are going to be get a common denominator on all pieces. So this one has 3 pieces. 1, 2, 3. And then once you have a common denominator, when you're solving an equation only, not when you're simplifying, but when you're solving, once you get a common denominator, you can drop the denominator. And then solve whatever equation that's remaining. So, with denominators of 2, 4x, and 4x, what is the common denominator that we need to get on everything? 4x. So this one needs a 2x. So we have 2x over 4x minus 9 over 4x equals 3 over 4x. We have a common denominator now on all pieces. So now I can just drop, drop, drop. What I'm technically doing when I'm dropping it is I'm technically multiplying both sides by 4x. It'll cancel all your denominators. So the equation that you have to solve is just whatever came from the numerator. So add your 9 over, you'll get 2x equals 12. Divide by 2 on both sides, you'll get x equals 6. Okay? if you jump down to exercise 5, my denominators all look very different. What do you think should come first here before you can even think about what that common denominator is going to be? Jason? Factor. Change this to the appropriate factors, x plus 5, x plus 3. And now, what does this denominator need? X plus 3. What does this denominator need? You're not looking at the board. Nothing is the answer. This one needs an x plus 5. And once I have that, I can drop denominator, drop denominator, drop denominator. So my problem ends up being x plus 3 times x plus 1, which I'll have to FOIL out, plus 18 equals 9x plus 45. So I'll factor that out, I'll solve it, and what two solutions, if they come up, will I have to reject? What do you think? -3 and a -5. Those are the two that, if they come up, I have to reject them, because they would make my original, if I plug them back into the original, they'd make them undefined. Okie doke. So once you get a common denominator all the way across and you drop those, the equation that you solve is either a linear or a quadratic, and you solve it per usual. Okie doke. When you FOIL this one out, it will be a quadratic.